Hi, NTeamEN, Nick speaking, and today we're gonna talk about the strong force. The strong force is the strongest of the fundamental forces of physics, stronger than gravity, electromagnetism, and the weak force. This force only acts on quarks, which are fundamental constituents of matter. By fundamental constituent of matter, I mean that they are not composed of something smaller. This force is carried by bosons called gluons. What I find interesting about strong force is that it does not work as the chosen forces we saw so far. Indeed, contrary to the electromagnetic force and gravity, the force between two quarks isn't reducing with distance. If two quarks get too far apart, the force that attracts them will get huge. This is why we can't see quarks outside of a group of quarks called hadrons, and in this video we're mostly going to talk about a certain group of hadrons called nucleons, because you require an almost infinite amount of force to separate two quarks from one another. Like we saw, the strong interaction is carried by gluons. Now we're going to see the effects of the strong interaction. As we saw, a strong interaction holds nucleons together, which are protons and neutrons. And that's good, because otherwise the world would not exist. The cohesion of quarks is done by a system of colored charges, not like the one we can see. Each quark has a color charge, either blue, red or green. With 3 quarks inside the nucleons, it has the 3 colors, and we say that it is white. And to complicate things even more, quarks constantly change colors, thanks to the gluons that holds them together. So yeah, the strong interaction binds quarks to make protons and neutrons, but it is so strong that it even holds the nucleus of atoms together. Indeed, in the nucleus there are protons and neutrons, but protons want to stay far apart from one another. So how can they form a stable nucleus that doesn't break apart? Well, that is thanks to the strong force that attracts nucleons. And the nucleons attract each other by exchanging pions, particles that have one quark and one antiquark. That's how atoms that make up matter can exist. If you listen during this video, you now know what is the strong interaction, a very strong force with a very small range, 10 to the negative 15th power. So yeah, that's all for this video. I will see you next week.